So welcome dear learners in week 6 lecture number 16 for introduction to electric vehicle and hybrid electric vehicle. So in this particular lecture we will discuss about the battery management systems exclusive for electric vehicle. In our previous lecture we have discussed about the basics of various energy sources associated with the electric vehicle like batteries and fuel cell and ultra capacitor. And also we have seen the different types of EV batteries like lithium ion battery and lead acid batteries and nickel based batteries, and also we have discussed about the recent trends in lithium ion battery technologies. So in this particular lecture we will basically discuss about the fundamentals of battery management systems for electric vehicle. Also we will see the different functionalities of a battery management system. Additionally we will see what are the different topologies and types of BMS. Also we will see the typical structure of the battery management system. At the end we will see what are the different research opportunities are available in the domain of battery management system. So let us first understand what is the battery pack. As you can see in this particular figure, there are two types of lithium ion battery packs which are exclusively made by different cells. Okay. So here you can see the cell is connected in series and parallel manner to form a module, and module are connected in series to form a pack. Basically this formation is done just because of to achieve our desired power level and voltage level. Here you can see there are two types of battery packs. The first in figure A, as you can see, it is a prismatic battery cell, and in B you can see it is a cylindrical structure. So depending upon your application we can choose any one. However, the prismatic batteries packs having more power density compared to the cylindrical structure for the same application. As you can see, the lithium ion battery packs are available in the form of cells which is made which is connected in series and parallel manner. Okay. So in this way we can enhance the pack capacity. Okay. Now let us understand what are the different terminology associated with the battery management system. As you can see in the figure 1, the BMS for the electric vehicle is presented. Here you can see the battery pack is connected with BMS, and BMS is connected with the AND terminal of the battery packs. So we can say the BMS is considered as a link between main battery pack and the external devices, including your charger, your load, your display systems and other peripherals. So the main function of BMS here is to monitor, protect and optimize the performance of the battery pack. BMS is the electronic circuit which is made to form a link between the main battery pack and external peripherals. So here the main function of the BMS is to monitor the current, voltage, temperature and other parameters to perform various functions such as optimization, protection and other activities. Okay. So here you can see by monitoring the current, voltage and temperature we will see the current state of charge of the battery. Also we can measure what is the state of health of the battery, and according to the different electrical parameters and thermal parameters we can manage the thermal management can be done for the BMS part. Also this BMS having the communication protocol like CAN, so that we can communicate with other peripherals such as display system, such as our battery chargers, such as with our load like EV. Okay. And if you consider the total cost breakdown of a EV battery, then as you can see the 10% of the total cost is given to the BMS. It is very significant cost if we talk about the EV batteries. No doubt the majority of the cost is given to the cell because if you consider India, then most of the EV battery cells like lithium ion battery cells are imported from the other countries. So that is why it is in higher cost side. So, but still we are having the 10% where we can contribute to minimize the cost. Now, let us focus on the different functionality of the battery management system. In order to achieve the efficient operation of electric vehicle as well as to extend the battery cycle life, the battery should include the following functionalities. The first one is the battery cell voltage measurement. It is very important to measure the voltage of each and every cell of a particular pack to get so that we can see what is the state of charge of individual battery cells as well as the state what is the state of charge of the whole pack. Also, this voltage is critical to what we call for the cell balancing. Okay, and once it is in normal case, most of the time cell battery voltage measurement can be done using the different potential divider method. However, we can also use the different types of Hall sensor, but it is a costlier choice. So, that is why the potential divider method is mostly used to measure the battery voltage. The second most important parameter is the battery temperature measurement. The battery temperature measurement is very critical if you consider the individual cell. Nowadays, you have seen many incidences for the EV charge fire, EV vehicle fire cases. Okay, so BMS inappropriate BMS design is one of the reason for the fire. So we have to design the thermal management very efficiently so that your battery should not get fire. So for thermal management, we use the different temperature sensor at individual cell level. Subsequently, we will measure the pack current measurement. Pack current measurement is nothing but a total current drawing from the battery or giving to the battery. Okay. So normally it is done through a shunt resistor because it is the cheaper options. Okay. So and with the help of this current we can check what is the current status of the battery pack, whether it is in faulty condition or it is in a normal operating condition. The next one is the battery total voltage measurement. It is very important to monitor what is the ultimate battery pack voltage, because if we consider the load, then load is very much concerned about what is the total battery pack voltage level. Okay. So that is why we are measuring the total voltage of the battery pack. The next one is the insulation resistance measurement. Insulation resistance measurement is very crucial to check what is the status of your battery pack, whether it is in faulty condition or it is in normal condition. Like there are different types of fault like short circuit fault and open circuit fault. Those faults can be analyzed using this insulation resistance measurement. The next one is the thermal management. Thermal management is also carried out by the BMS by using the different temperature sensor, and once the temperature is reaching beyond its operating limit, it is automatically cut the load from the battery pack to ensure the safety of the battery and safety of the person who is handling the battery. The next one is the state of health measurement. State of health estimation is very much crucial in order to ensure the proper life cycle optimization and life cycle utilization of a battery. And subsequently, the state of charge. State of charge is very much important, as you can see you can see in your mobile. It is basically showing the state of charge. So in the similar fashion, the state of charge is very much important for the lithium ion battery pack as well. So we have to measure this SOC in a very accurate manner. Nowadays we are having multiple ICs which can perform all those functions which are listed in this particular slide. Okay. And next one is the analysis of the battery fault and online alarm. No doubt we have to give a alarm system for the end users. So alarm is mostly given by using a display. Okay. So display, there are multiple way to inform the user that current state of battery is in faulty condition. So we have to analyze those fault and we have to communicate with the display device appropriately. Next one is the communication. Communication is one of the important function of the BMS system in order to get the current status of the battery pack and inform the other peripherals in case of any abnormal condition. The next important function of the BMS is the battery discreteness in each pack. It is very important function in order to initiate the cell balancing action. The next one is the recording of charge and discharge time. It is very much crucial to measure the discharge and charge time in order to get the optimized battery performance. Now, let us discuss the different topologies, or we can say that the types of the BMS associated with electric vehicle. Basically, there are three types of battery management system: centralized battery management system, modular battery management system, and distributed battery management system. All three categories are defined based on the structure of the BMS. So, let us see, as you can see in this particular slide, the different structures of the BMS are defined here. As you can see in the top left diagram, the centralized battery system. In the centralized battery system, only one control unit is there which controls the whole battery pack. As you can see, it is the cheaper option, and it is mainly for the low power application. As you can see, whenever we require the higher power density, we will move towards the distributed battery management system, and whenever we are having the low power requirement or low power application, where we generally consider the centralized battery management system, whereas the modular battery management system is mostly used for the mid range voltage level and mid range power density applications. No doubt, whenever we are moving towards the low density power application to higher power density application, the number of cells will be increased. Okay. So, distributed battery management system is required for higher power application, and at the same time the distributed battery management system is a costlier choice compared to the centralized battery management system. And whenever we are moving from centralized battery management system to distributed battery management system, the total number of components will be increased, and subsequently the cost will be in a higher side. Let us understand the BMS for different voltage level and capacity level. As I have mentioned in my previous slide, there are multiple choice of the BMS, and as you can see, there are multiple application based on the different voltage level. As you can see, the BMS can be designed for a wide range of voltage level, from under 200 voltage to more than 800 voltage, depending upon the application. No doubt, the energy storage applications require more voltage and more power. Actually, there are multiple application of the lithium ion battery packs, such as electric vehicle, and second one is in telecom for the BTS side management, and subsequently it is also used in the robot, especially in the automated guided vehicle, more commonly known as AVGs, and also it is used in the data center for powering the different racks. Also, nowadays this lithium ion battery packs is one of the favorable choice for the home energy storage systems to provide more power and more power and more current in order to cater the high load in the home system. So, let us understand the typical structure of the battery management system. Here you can see the battery management system are discussed in a different blocks. As you can see, the battery packs are basically a interconnection of different lithium ion battery cells. Okay. So, this battery packs is communicated with our microcontroller or our battery management ICs. There are multiple battery management ICs are available of different manufacturer. I will show in subsequent slide as well that there are lots of application specific ICs are available, which can readily used to design any battery management system for a specific application. So, basically the measurement require different electrical parameters, and those electrical parameters are measured by different types of sensor. Okay. Mostly the electrical parameters like the current and voltages are measured by the shunt resistance and potential divider method in order to get the voltage and current of the battery pack. Also it is very critical to balance the voltage of each cell, which can be done by cell balancing. Basically there are two methods of the cell balancing. The first one is the passive cell balancing, and next one is the active cell balancing. The passive cell balancing is carried out by simple shunt resistor. However, it is a cheaper choice, but at the same time the power dissipation is more in this particular passive cell balancing. Whereas in second case where active cell balancing is used, so in active cell balancing the cost will be in higher side, also it will increase the size of the PCB, and at the same time it will reduce the power dissipation. So if you are like if you are performance oriented, if your consideration is the performance is the highest priority, then you will consider the active cell balancing. But if the cost is the important priority, then you will consider the passive cell balancing. Okay. And next important block is the CAN bus controller. Okay. So there are multiple CAN ICs are available, which are used in the battery management system to communicate with the other devices, such as your battery charger, your other peripherals, such as your display, your microcontroller, and your other part of the battery management systems. Okay. So CAN protocol is very much important, and nowadays most of the battery manufacturers are providing their own display and their own what we call the web interface, so that you can monitor your you can monitor various parameters associated with your battery packs at any remote location. So for that purpose you require a CAN communication. So there are multiple ICs are available of different manufacturer that can be easily integrated with your BMS, so that the functionality of your BMS will be enhanced, and no doubt it will also enhance the overall performance of the battery pack. Let us discuss the different types of BMS ICs. There are multiple manufacturer like Texas Instruments is one of the leading manufacturer of BMS ICs. Okay. So there is one part number that is called BQ76905. It is one of the part number. No doubt there are multiple BMS ICs are available with the Texas Instrument, but exclusively I have taken this particular part, but it is not limited to this particular part. We are having more part as well. In this particular slide we are discussing about the different types of BMS IC are available in the market. Okay. So Texas Instrument is one of the leading brand which is having the most of the part of the battery management system. If you go to the Texas Instrument website, you will find multiple BMS ICs. Okay. So they have exclusively categorized those BMS IC on the basis of different application. Okay. Because there is a wide variety of the what we call the lithium ion battery packs, and accordingly we are having the wide variety of the BMS IC. As you can see, I have mentioned one part number of the Texas Instrument, that is BQ76905. This particular IC having the 2 cell to 5 cell battery management system capability. Okay. So this particular part number can be used for the small application. However, this cannot be used for the higher application where we require the more power. So you can go through the TI website to find the different ICs for your application. They have very beautifully categorized those IC in a very effective way. Okay. Also they have given the reference design for that particular BMS IC. So those designs and technical notes are very useful if you are going to make your hardware ready. Okay. So I insist you to go through the TI website so that you can get more clarity on the BMS IC part. Also they have included the evaluation board as well. So those evaluation board can be used for your own reference design, and also you can design your own battery pack and your own BMS system for a particular application. Okay. So those design can be considered as a reference design. Subsequently, one of the major manufacturer of the IC and microcontroller is the ST Microelectronics. Okay. So they have also the ST having the exclusive range of the battery management ICs and microcontroller ICs. If you go through their website, you will find the multiple ICs are available. Those can be exclusively used for the BMS and for the design of the BMS. As you can see, there is one part called L9961TR. It can be used to design a BMS for the 5 cell level. However, there are other part as well which can be extended up to more than 20 cells. Okay. So depending upon your application, you can choose any ICs. Okay. So once you have tested those circuit, then you can go for the cost optimization. Okay. Because selection of the BMS IC is one of the critical part in order to get the cheaper BMS option. So selection of the IC is one of the important factor for the overall cost of the BMS. In the next manufacturer is the NXP. NXP having the exclusive range of the BMS IC. One of the IC I have mentioned here, that is MC33658TF4AE. Okay. So those these ICs also used for the battery management system. And subsequently we are having the MPSL. So we are having the MPS part number MP2796. It is also a battery management IC. I have taken only 4, but no doubt there are other manufacturers as well. Those are providing the battery management system ICs. Okay. So those battery management system ICs are exclusively made for the BMS operation. It can be and there are other peripheral as well. You can kindly go through their website and their reference design and their technical notes, which will be very helpful for the learners to make their own BMS at their laboratory. Okay. And also if you want to learn how to make those PCBs, you can use any open source software like EasyEDA, KiCad, and if you are having the commercial license of Altium, it will be very good. So those platforms are providing a very good tool for the PCB design. Okay. So you can check your you can design for your testing, you can design for your assembly, and you can design also for your manufacturing. Okay. So those can be done using this KiCad or any open source electronic design tools. Now let us see what are the recent trends in the BMS design. So here I have mentioned what are the research challenges which are associated with the battery management system. The first challenge which are associated with the active cell balancing. As I have mentioned in my previous slide as well, the cell balancing is a very crucial to get the optimized output from the battery packs. So considering the performance, active cell balancing is very good, because in active cell balancing generally we use the isolated DC-DC converter, so that the power dissipation can be minimized. So there is a research opportunity in the active cell balancing design for the battery packs. Okay. So if you will have a better active cell balancing in your system, then definitely you can increase the overall what we call the mileage, or overall what we call the range of your vehicle, because you are optimizing the battery pack. Okay. So cell balancing can be included like active cell balancing. So there is lots of opportunity to what we call the design the active cell balancing. So you can have a what we call the a good research gap in active cell balancing. Okay. And the next research gap that we have is the optimized selection of charge and discharge MOSFET. We have encountered many problems associated with the charge and discharge MOSFET. Most of the time they got burned and they are more prone to the fault. So optimize selection of the MOSFET and their gate driver circuit is very important. So, you have to ensure the chosen gate driver and MOSFET are appropriate for your application, considering the current, voltage and other parameters. Okay. So, you have to design, you have to select and design your gate driver circuit such as it should have a minimum EMI on overall BMS in order to get the different compliances associated with the EV battery packs. The next important parameters which is having the good research gap is the efficient thermal management. As you have seen many incidences where the EV like a two-wheeler and four-wheeler got fire. Okay. So, one of the, as I have already mentioned, that this BMS is having the the inappropriate design of the BMS is one of the reason for the fire. Okay. So, we have to design our BMS such a way and in an efficient way, so that in case of any fault our BMS can be isolated, our BMS can isolate our load from our battery pack. So, such a fast dynamic response is required in case of the battery management system. So, this is a very good research gap. So, you can include this thermal management part in your what we call in your current course as well, and you can take this particular thermal management problem as a research problem. Okay. So, in thermal management there are two aspects. The first aspect is the temperature rise in a battery pack, temperature rise in a cell and temperature rise in a MOSFET. So, that they all three should be considered in a very appropriate manner, and there are in most of the cases to manage the temperature of the MOSFET, we generally use the heat sink, and sometimes we also use the forced cooling, and we are using the one fan, dedicated fan for a particular MOSFET. Okay. And next one is the minimizing the PCB size. As we know, the size of the battery pack is very much crucial for any electric vehicle. Okay. So, PCB, the size of the PCB is also very important to get a good orientation and a good what we call the geometry of your battery packs. So, correct appropriate selection of the components, appropriate placing of the component, and what we call the appropriate PCB design is the key for the optimization of the size of the overall battery packs. Okay. So, there is a research gap in minimizing the PCB size as well. So, those can be done using the appropriate selection of the components and good PCB design. So, this is the summary of this particular lecture. We have discussed the fundamental and the basic function of the BMS. Also, we have included the different topologies of the BMS which are exclusively used in the electric vehicle. Also, we have understand the different functions associated with the battery management system and what is their role for the overall functionality of the battery packs. At the end, we have discussed the future research trend in BMS and also we have taken we have seen what are the research problems are currently facing the industry. So, this is the topic that we will cover in our subsequent lecture. The BMS part 2 we will discuss. We will see what are the different design consideration associated with the BMS. Also, we will see the application of different ultracapacitor and flywheel in electric vehicle. Thank you so much.